All right. Welcome to segment 2 of our first podcast. We're going to be talking about the Ultra High Performance Concrete Initiative, which has recently ramped up, but has been in progress for quite some time now. So if you want to introduce yourself, we can get started.
Hi, my name is Sri Sridharan. I'm a faculty member in the Civil Construction and Environmental Engineering. I've been working with ultra-high performance concrete for nearly 20 years. My focus with this material is more in structural applications rather than on the material side of the UHPC.
So we got a little bit of a preview before we started recording, but what makes ultra high performance concrete ultra high performance?
The ultra-high performance concrete is, it's a new class of concrete material. It's a cementitious material, but the benefit of or the features of ultra-high performance concrete is that it uses very fine particles. So it doesn't use large aggregates like typically you see in concrete.
Okay.
All of them are used in powdered form. The largest particle you see in ultra-high performance, or we often refer to as UHPC, is 600 microns. So the different constituents go into ultra-high performance is also higher quality material. So you
Okay.
can buy them with a certain degradation range, if you like. One of the other feature that you see in ultra-high performance that you haven't seen in normal concrete is that it uses steel fibers.
Oh, okay.
So steel fibers, they are typically half-inch in length. Again, small diameter, and that also helps the material to perform the way it performs.
Okay. So it kind of has a structure within the concrete.
Correct.
Okay. That's really neat. How did this initiative kind of come about?
So the UHPC has been used in the U.S., I would say, in terms of applications from early 2000, I would say. So we started playing with this material. When I say play, just use small samples, testing to understand the material behavior. But the state of Iowa has taken a big leap in the use of this material nationally. I say that because we are the first one to build a bridge using this material in Iowa.
Wow.
So in the U.S., the first and maybe second and fourth UHPC bridges were built here in Iowa. There's a reason for that. I think we work closely with a number of collaborators, including Iowa Department of Transportation. So that collaboration helped us to move some of the knowledge from the university level to practical applications. Or sometimes, some of these projects are driven by the DOT, but we support it in terms of how they should be using the material.
Okay. So the initiative is kind of housed at Iowa State, but it goes beyond.
Coming back to your initiative question is, even today, close to 17 years, we've been using, 17, 18 years, people have been using. When we started, there was only one supplier in the U.S. And we now have maybe half a dozen or more UHPC suppliers in the U.S. The market is still small. We can talk about as to why. So there's a lot of competition, but if you look at the total quantity, we use very little.
Okay.
I think yearly consumption I would put at 3,000, 4,000 cubic yards.
Wow.
So that's nothing
Yeah.
compared to the concrete use. So I don't know if you know this, the second most consumed material in the world is concrete.
Wow.
Do you know the first most consumed material?
No?
It's water.
Oh, well, that makes sense. Yeah.
So you can see
Water
where concrete.
and concrete. Wow.
So the amount of UHPC that we use is pretty limited.
Yeah.
There are a number of reasons for that. There's a material innovation. There is basic research needs, and the DOT's owners are willing to explore this material.
Okay.
But there's no common forum where we all can come together and work together without competing with each other. So the initiative was designed to bring members together with a common interest. So we only talk about the common problems. with the intention that how do we grow the market sector? That's the ultimate goal for us.
Yeah, and that would benefit everybody, even in competition with each other.
Absolutely, absolutely. So yeah, we even have an antitrust policy so that they have to follow the antitrust policy. So we don't talk about each one's material, the cost. None of this is allowed in the meetings.
Mm-hmm.
But we talk about how do we, what is needed so that we can advance the use of UHPC in the market sector.
So what would bring somebody to want to use ultra high performance concrete in a structure versus the regular old concrete?
So if you look at the regular concrete, so one of the problems with the regular concrete is its durability is not that great compared, when you look at it. So if you were to look at structure, so if I take a bridge structure, the decks are expected to last 20, 30 years. Structure is expected to last 50, 60 years.
Mm-hmm.
But if you look at the maintenance cost and the condition of bridges, it's fair to say that we do replace deck more frequently, maybe 4 to 5 years time frame. So that adds up to the maintenance cost, and any times the bridge deck fails, the moisture will get in, and it will start to damage the other components as well. So
And the bridge deck is like the
surface on
road.
the top, basically
Okay.
what you ride on.
Okay.
So that's where the problem starts. So one solution would be to make it more durable.
Mm-hmm.
And number of other technologies have been tried over the years. And I don't believe anything has satisfied the owners in terms of improving the performance,
Yeah.
even the cost that they're putting in. One of the biggest advantage of UHPC is that it has a very durable property, or high quality durability properties.
Okay.
So the reason the US is driven for UHPC is more towards handling these durability properties, especially in the Midwest and the East Coast.
Mm-hmm.
The UHPC around the world is actually being used for different applications, different reasons. But in the US, the market growth is more to do with how do we use the material so that we can prolong the longevity of structures, basically,
Yeah.
or lifespan of the structure.
And that kind of lends to a sustainability aspect of this as well.
Yeah, so if you incorporate the long-term benefits,
Mm-hmm.
which is not often done in a
Yeah.
project-by-project basis, because people, there are different peoples in different sectors making decisions, and so some of them have a short-term objectives.
Mm-hmm.
So I'm not blaming anybody, but that's the objectives.
Yeah.
So they look at, okay, how many bridges we can tackle versus
We can get this done in this number of
exactly.
Yeah.
But yeah, if you bring in the longevity component in the mix, I would think that you will see the benefits.
Okay. And what are the financial aspects? Is this more expensive to produce? Well, I kind of assume so based on how small the market is relative to concrete in general. What would that look like for somebody to buy into?
Yeah, so one of the disadvantages of this material is the cost.
The cost.
It is more expensive than regular concrete. If you want a number, it could argue it costs 8 to 10 times the regular concrete.
Okay.
So it's more expensive. So again, if I'm going to build 10 bridges, I would rather use smaller, lower cost material and build 10 bridges rather than building 2 and not having bridges. So that challenge is there. So that's what we focus on. What would be the best application for a given problem? How do you use the material so the benefits are greater? But the cost should not stop us from using the material. I'll give you a completely different example. So I know we've been comparing the UHPC to regular concrete.
Yeah.
But one should also compare it to steel structures.
Okay.
So if you take a cubic yard of concrete and UHPC, I've given you a number, 8 to 10 times more expensive.
Yeah.
But if I take a cubic yard of steel and compare to the regular concrete, that number is a much higher number. But
Yeah.
we still use steel for construction,
Yeah.
right?
So what's the barrier to
Yeah,
adopting this? Yeah.
Yeah, so So the innovation has to take place, even the material. And in fact, if you look at the UHPC structures, there are some structures built around the world with the UHPC. They don't look like concrete structures. They don't quite look like steel structures. They look like somewhere in between. So that's where we need to go. It takes time to, so the mindset is always, okay, how do we replace the concrete? In fact, if you look at most of the solution, they look closer to steel than concrete. So the moment you start comparing to steel, it makes a lot of sense and you see the benefits.
Yeah, it's almost a false comparison in that aspect.
Correct.
Yeah. Wow. Okay. Do you want to talk a little bit about your current research and the industry impact with that?
So we have been doing research since, as I said, early 2000
Yeah.
on ultra high performance concrete. One of the things, so personally, what I have done is mostly looking at unique applications. Where would it make sense? So the applications I've been involved in. So first, we started with using a UHPC in a concrete girders. That's the very first project that used UHPC in the U.S. and that was built in Iowa. It was to try and use the material and see, do we like this material? Do we see the benefits? Quickly we realized that when I say we, the collective, the DOT, the precaster, the researchers, and everybody, it works well. There's a lot of benefit, but you cannot justify the cost. Then we moved to the bridge decks and said, okay, maybe if we protect the bridge decks, the rest of them can be in regular concrete.
Yeah.
So there was a project which developed what's called a waffle deck bridge. The waffle concept is like what you have for breakfast. It looks like that. The reason we do that is then you use less material. It's not a solid, so you can see the cost issue we compensate by using less volume of it.
Yeah.
That was we demonstrated, and I know there are people from outside the U.S. came and looked at it, and they started deploying some of those technology. In the U.S., we still have to justify the cost of the deck.
Yeah.
At the end of that project, we had a debrief with everybody, and we had a counterpart in Iowa DOT as a chief engineer. So he looked at it and said, okay, this is great, but can we, instead of doing it for the entire bridge deck, can we do the top layer?
Oh.
Because then we can do more bridges.
Yeah.
And but he put some conditions and funded a project. So we came back and looked at what's the best way to just peel off the top layer of concrete and replace it with this material. And that's where the overlay concept came about.
Wow.
And so basically we have done research to promote this idea. The moment I completed the research, I knew it's going to be a big hit.
Yeah.
Because we're using less material and we're protecting surfaces, pretty effectively.
Seems like a win-win.
Yeah.
Yeah.
So we probably have done, I would say, 7-8 bridges here in Iowa. Nationally, I think people have done, at least in 12 states, they've used the technology. And last year, or they probably finished the project this year, is the Delaware Memorial Bridge. The entire bridge of one, it's a twin bridge, so one of the bridge entire deck was actually replaced with the overlay concept, and at a $73 million contract.
Wow.
So I think that is going to continue to grow. I don't believe that we have solved all the problems. We still have unanswered questions. So that's one of the topics that we explored within UHPCI in terms of what is that we need to do to make it more effective and allow UHPC this concept to be used more DOTs, because they do have some concerns, questions, quality assurance issues.
Yeah.
So we're exploring that to go to the next. So we will help them grow this market sector.
Yeah. There's an educational aspect that.
Correct.
Yeah.
So some of these ideas, so at the end of the project I work on, we came up with a pile made out of UHPC. Concrete pile has some benefits. Steel pile has some benefits and challenges. And UHPC sold all of them. So we developed a pile. I think that was done in about 10 years ago, 11 years ago. I think places like, coastal states like Florida should use them day in and day out. But they're very slow to adopt some of these things. And now I think I would say our first report came out in 2011. 13 years later, Florida actually has a design guide to use the concept that we developed 11
Wow.
years ago. And then, they're going about how they want to implement in the field. So these things happen, takes time.
Yeah.
Another unique application I've used the material is the designing a new wind turbine tower concept. And we've done all of the works, we've evaluated, we tested. So I'm pushing to figure out a demonstration project now. The idea here is to build tall wind turbine towers. So the one you see, in Iowa, for
In the
example.
fields.
Yeah.
Yeah.
So they're about 80, 90 meters. And our goal is to go to 120, 140 meters.
Wow.
So by doing that, you could actually virtually build wind turbine towers anywhere in the U.S.
Yeah.
So all 50 states can build, as opposed to now some states saying, oh, we don't have wind. We don't have wind because we are going up only 80 meters. So if you go 120 meters, there's wind.
There's going to be wind up
Yeah.
there. Yeah.
And even in Iowa, it's certain counties are benefiting. There's a challenge in the sense, anyway, if you develop electricity away from where your demand is, you have to transport them.
Yeah.
So this tall tower concept can help. And people question me, so why do you want to use it UHPC instead of regular concrete? So if I convert everything, every concrete piece from regular concrete to a UHPC, I'll cut down the tower weight by 50%.
Oh.
So the most expensive item in wind farm construction is the crane time. So if I can cut down the weight, the crane time will be minimized. So even though I'm putting more material, I'm saving a lot on crane time. So we've done an exercise in terms of what would be the time frame if I were to build a wind farm with 100 towers, and collaborated with our construction folks in our department, and we showed that's the direction to go.
Wow. That's really cool.
So I give you these examples because we hardly look at material cost, but the benefits comes at the end if you figure out the right application.
Yeah. It's the collective working all
Exactly.
together versus just pinpointing the material that you're
Yeah.
making.
So if you see a rectangular beam that you want to replace it entirely with UHPC without thinking, it will be expensive.
Yeah. But
You shouldn't
that's
be doing
not the
that.
real application.
Correct.
Yeah. Okay. So what are your current partners for this initiative, and kind of what are your goals for the future?
So we asked, so it's a kind of a initial stage. We came together, we developed a bylaws in terms of how we want to operate. We have talked about what the emphasis should be. The members pay a small due, and that money goes towards some seed research that we will do. And members decide what seed research that we would need to perform, so that we identify the problem, clearly define it with some seed data, so that we can go to the sponsors for doing the follow-up research. So right now we have 3 material suppliers. Ductal, it's a Lafarge's subsidiary. Ductal is the first one to introduce UHPC to the market, so they're one of the members. CNTech is another company. They are marketing their material here in the U.S. It's a Singapore-based company, but they have an office and distribution here in the U.S. We have a Dura Canada. Dura is the material is basically developed in Malaysia. They are marketing their product through this Dura Canada. It's a construction company. So we are working with them. So they are one of the members as well on the material side. There's a company called UHPC Solutions. They are contractors, so they look at doing UHPC projects. So they are one of the members. We also have 2 DOTs joined. One is Iowa DOT. We have different structure as to how a DOT can join, and then California Department of Transportation is also part of the group. So we have 6 members now. We're formalizing the plan, developing a website, and hopefully we'll open it up and see who else may want to join.
Yeah.
So as I said, the initiative is going. The target is to figure out the common problem. A material supplier and the contractor has to work together on the field. Somebody has to assure quality assurance. So unlike the regular concrete where bad quality concrete show up to the field, they look at the quality and they send the truck away, they lose, maybe a couple of $1,000. You can't do that with this material.
Yeah.
So, you will be looking at losing $10,000, $15,000 if you turn a truck away.
You need someone that knows what they're doing.
Yeah. So we're trying to figure out, so the main purpose is to work with them to identify their concerns and challenges in the field and make sure that we provide them. So the material is very sensitive to the environmental conditions. So whatever I mix in the lab will not be the same when somebody mixes in the field in a hot day, hot summer day.
Different variables.
Yeah. So they're very sensitive to that. So things like that is what we want to come together. So we're working on a series of best practice documents that they can use it. They can give it to contractors. They read through. This is what we expect you to do. And then we also would do seed research in terms of common problem. Again, the university doesn't dictate what research to be done. The members decide what needs to be done. So there's a precedent for doing research like that when members put in some money to create seed research. Campus has a number of organizations, so we're kind of trying to follow that model.
Yeah. Yeah, you're trying to address the problems before people see them in the
Right.
field. That makes sense. Okay. This is just something I'm asking for fun.
But
So the bridges in Iowa, are there any examples that you can point to or towns that have some examples of the ultra high performance concrete in action that we can take a peek at even if we don't fully understand?
yeah, so typically when we do these projects for demonstration purposes, we will work with the counties. So there are a couple of bridges in Wapella County
Okay.
with UHPC in it. Because the county engineer was very excited about using UHPC.
Yeah.
His name is Brian Moore. He's no longer there, but certainly the bridges are. And Brian Kai Labor is the county engineer for what county is in? I should know this. If I come, I'll let you know. So Brian is so he also a supporter of UHPC. So when we have some demonstration project, we put some of the bridges in his county. So that's a common thing that the DOT likes to do. They try these things, new technology on a low volume bridges to make sure that our expectation is work out the way we expect,
Yeah.
and performance is good. So they do some field evaluation as well after the structure is constructed. So once that is done, they will move the technology to the main highway system.
Okay.
So 169 going towards from Des Moines, 169 going east.
Okay.
There's a bridge was done with the UHPC. In Cass County, there's one main bridge done last year. So they're popping up more often.
That's really neat. We drive over them every day. I probably wouldn't
you
even know.
Yeah, they don't look any difference
All right.
unless you stop and look at it closely.
Yeah. This might come out before our website is ready. But if people are interested in this initiative, what should they do next?
Yeah, so they could reach out to me. My email address is easy to remember, is sri@iastate.edu. People interested in this area should know Vic Perry. Vic Perry is the current president of the CNTech, the U.S. operation, and Vic is the current chair of the advisory board for the initiative, and so they could reach out to him, and we will be happy to answer questions.
Okay. On a student level for our Iowa State CCEE peeps, are there undergraduate research opportunities or ways to get involved there?
Yeah, so there are more and more faculty are doing UHPC research in the department. Kejin Wang does more on the material side. Behruz Shafee, he uses UHPC for some applications that he's looking at, structural applications. And I do recruit undergraduate students. In fact, I have one that working right now doing some undergraduate research, certainly they can explore opportunities within the lab. And we have, I think between us and connecting with the industry, we work with a number of industry folks, and we probably have materials from almost all of the suppliers in the lab.
Wow.
If anybody's interested, certainly they can explore these opportunities.
Sweet. Well, thank you for coming on and talking about ultra high performance concrete. This is exciting. It sounds like there's lots of opportunity if people are interested. So,
Thank you. That was a great opportunity to talk with you.